Friends, in this video we shall try to understand the rules for rounding numbers, particularly numbers obtained by measurement. Let us say this is the measured mass of an object, and in this measurement we know the mass of this object up to 4 decimal places, and there are 6 significant figures in this measurement. Wherever we need the mass of this object up to 4 decimal places or with this degree of precision, we can go ahead and use this number. But there may be some cases where using the mass of this object up to 4 decimal places is not going to do any benefit or good to us. Maybe in those cases, knowing the mass up to 2 decimal places is sufficient. So in those instances, using the mass of this object up to 4 decimal places is going to make our life harder, because sometimes you have to multiply this number with another big number or divide this number with another number. In those instances, having more digits would make the calculations more difficult. So in those cases, we would like to drop some of the digits from this value, or we like to make this number simpler with fewer number of digits, and this is what we call rounding. Also, sometimes we need to round the results of arithmetic operations, that is, the results obtained by performing addition, subtraction, multiplication and division on some numbers. I will explain these scenarios in the next video. But whatever may be the reason for rounding, the process is going to be the same. Rounding is making a number simpler or shorter. Now let us try to understand the meaning of rounding with the help of an example. In this number there are 4 decimal places, but let us round this number to 2 decimal places. And if you need only 2 decimal places, one thing you could do is simply chop or cut off the unwanted digits without worrying about anything else. Then the number becomes 34.01 grams. Fine. Then what about another measurement that has a value of 34.0189 grams? Again, you would do the same thing, right? Chop these numbers off, it becomes 34.01 grams. Then what about 34.0199 grams? Again, you would chop off these numbers and make it 34.01 grams. So, in all these instances, because of this chopping, the value you are obtaining is always less than the value you have started with. And this process of chopping of digits from a number without worrying about anything else is called truncation. And remember that the truncated number is always smaller than the number you have started with. Because of this reason, the average of the truncated values is always smaller than the average of the numbers you have started with. And if that is not a problem for you, go ahead and truncate them. No problem. But what if you don't like that? What if you want these two averages to be equal? Then obviously you cannot truncate, right? Then what should we do? Now, before we go any further, let us understand the meaning of a few terms or the vocabulary that we are going to use in this video. Let us consider this measurement again, that is 34.0146 grams. In any measurement, significant figures are counted from left to right. So in this example, this is the first significant digit and this is the last significant digit. And because the first significant digit has a higher place value than any other digits in that value, it is also known as the most significant digit, and obviously this becomes the least significant digit. That is about the digits in the original measurement. Now what are we trying to do? We are trying to get rid of the last two digits from this number. Remember, we wanted to round this number to 2 decimal places. So these are the only digits that we would have in the final result. So these are the significant figures in the final result. And we are no longer interested in these digits that we are dropping. So they are no longer significant to us. We don't care about them anymore. So we call them non-significant digits. So this is the last digit in the final result, or this is the last significant digit, and this is the first digit that is getting dropped, or this is the first non-significant digit. So try to understand these two terms. The last digit that we are keeping or retaining is the last significant digit. The first digit among the digits that are getting dropped is the first non-significant digit. Take a moment to understand these two terms. Now let us get back to our business. How do we get rid of these two last digits in each of these cases while keeping the average the same before and after the change? As we previously discussed, truncation would not work. Then what can we do? Let us say this end of the line represents the number 34.01 and this end 34.02. Then this number 34.0146 is somewhere between these two, right? Probably near the center of these 2 points. Somewhere here, I think, 34.0146. Then 34.0199 will be somewhere very close to this end, right? It is almost 34.02. So this is 34.0199. Now what did we do in case of truncation? We simply chopped these last two digits in each of these cases and dragged all these measurements towards this lower end of the line. That is why the average of the truncated values is always less than the average of the original values. But we said that is not acceptable for our purpose. We have to keep the average the same before and after. Now how do we keep the average the same? If you take a large number of measurements, then all those measurements are scattered all over this line. And if you drag all the measurements that are close to this end of the line towards this end, and all the measurements that are close to this end of the line towards this end, then the average would remain the same. Now, because 34.0199, that is this number, is closer to 34.02 than 34.01, we have to convert it into 34.02. How do we do that? Simple. Look at the last digit that you want to keep, or the last significant digit, and add 1 to it. And drop all these non-significant digits, the digits that we are trying to get rid of. Similarly, because 34.0146 is closer to 34.01 than 34.02, we have to convert this number into 34.01. But how do we do that? Simple. You simply have to drop these two digits. Remember, in this case, you do not have to subtract anything from this last significant digit. Kindly notice that. So, if the number is close to this end, then simply add 1 to the last significant digit. And if the number is close to this lower end, then simply drop these non-significant digits and don't subtract anything from the last significant digit. So pay attention to that. Now dragging a number to this upper end is called rounding up, and to this lower end is called rounding down. Now the question is, just by looking at a number, how do we tell whether to round it up or down? Simple. We can imagine that this line is divided into 10 equal divisions, then the midpoint will be at 5. Now look at the first digit that we are dropping, or the first non-significant digit. If its value is less than 5, then simply drop these non-significant digits, round it down. If it is greater than or equal to 5, then round it up, that is, add 1 to the last significant digit and drop the non-significant digits. As simple as that. But there is a problem with this. Now, what is the problem with rounding down if the value of the first digit to be dropped is less than 5, and rounding up when its value is greater than or equal to 5? See, these are the only possible values for any single digit, right? So, the first digit to be dropped, because it is a single digit, can have only one of these 9 values. And we are saying if it has any of these 5 values, round it down. And if it has any of these 5 values, round it up, right? Greater than or equal to 5, less than 5. So when the value is 34.010, this is the first digit to be dropped, or 34.011 or 012 or 013 or 014, round it down. If it is 34.015 or 016 or 017 or 018 or 019, round it up. So in all these cases, we have to make it 34.01 by dropping this last digit. And in all these cases, we have to make it 34.02 by adding 1 to the last significant digit and dropping this non-significant digit. Now, if you look at these 5 cases, only in these 4 cases, dropping this digit would change the value of the number. In this case, dropping a 0 would not change the value of that number, because 34.010 and 34.01 have the same value. So, in this case, dropping this 0 has no impact. But in these 4 cases, we are changing its value. But on this side, in all the 5 cases, we are changing the value of the number. So out of these 10 cases, only in 9 cases the value is changing, out of which 5 of them are on this side and 4 of them are in this side. So there is an imbalance because of this 0. And because of this reason, you will not be able to keep this average the same, because you are effectively rounding down only 4 out of 9 cases and rounding up 5 out of 9 cases. Now, to strike a balance again, we have to change this rule slightly. Instead of rounding up when it is greater than or equal to 5, round it up only if it is greater than 5, that is only in these 4 cases, and round it down in these 4 cases. Remember, 0 doesn't matter. So out of these 8 cases, 4 are on this side and 4 are on this side. So we again struck a balance. Now we have to deal with 5 separately. That is, we have to come up with a different rule when the first digit to be dropped has a value of 5. Now what should we do if the value of the first digit to be dropped is equal to 5? That is, in this case, should we round it up or round it down? Now that depends on the value of the last significant digit or the last digit that we are keeping. Now what are the possible values for the last digit that we are keeping or the last significant digit? One of these 10 values, right? It is a single digit, out of which 5 are even numbers and the remaining 5 are odd numbers. Remember, 0 is an even number. Now, if it is an odd number, round it up. And if it is an even number, round it down. Simply drop the non-significant digits. Again, there are 5 even numbers and 5 odd numbers, so we achieved a balance. So, by following these rules, we are able to divide the measurements equally between rounding up and rounding down. Thereby, we are able to keep the average the same before and after rounding. And that is why we came up with these rounding rules. In case if you are wondering the background of these rounding rules, that is what I have explained so far. Now I will read these rounding rules for your convenience. If the first digit to be dropped is greater than 5, then round it up. That is, add 1 to the last digit that is retained. If the first digit to be dropped is less than 5, then round it down. Simply drop all the non-significant digits and do not subtract anything from the last digit that is retained. People usually do this mistake. And if it is equal to 5, then round it up if the last digit to be retained is odd, and round it down if it is even. That is what we have discussed here. And you will understand this better with the help of some examples. Now here are some examples. It says round the following to 3 significant digits. Remember, significant figures are always counted from left to right. So in this example, 1 is the first significant digit and 5 is the third significant digit. So we are asked to keep 3 significant figures and drop the remaining digits. Now, should we round up or round down? For that, you have to look at the first digit that you are dropping. And it is a 6. Because it is greater than 5, you have to round up. That is, you have to add 1 to the last digit that you are keeping and drop all the digits to its right. So it becomes 1.96. In this example, again the first significant digit is 1, the third significant digit is 0, and we have to drop these last 2 digits. And to know whether to round up or down, you have to look at the first digit that is getting dropped. You don't have to care about the remaining digits that are getting dropped. And because it is less than 5, you have to round it down. That is, you have to simply drop these digits that you are not interested in and don't change the digit or the last digit that you are keeping. So it becomes 1.80. Don't subtract a 1 from this. Now in this example, again the first significant digit is 7 and the third significant digit is 1. So we have to keep these 3 digits and drop this 5. Now the only digit that is getting dropped here is equal to 5. Then should we round it up or down? If it is equal to 5, then whether to round up or down depends on the last digit that you are keeping. Is it an odd number or an even number? Odd digit or even digit? odd digit, right? And according to our rules, if it is odd, you have to round up. That is, you have to add a 1 to this last digit 1, so it becomes 7.82. Now what about this case? Again, the first significant digit is 1 and the third significant digit is 6. So we have to drop these two digits. And again, the first digit that is getting dropped is equal to 5. In that case, to round up or not depends on the last digit that is retained. In this case, it is a 6. This is an even number, so you have to round it down. That means you have to simply drop these two digits and leave the last digit as it is. So it becomes 9.16. Now what about this case? Remember, in this case, 0 is not the first significant digit. 1 is the first significant digit. So we have to keep 1 to 0 because this 0 is the third significant digit, and we have to drop this 8. And 8 is greater than 5. The first digit that we are dropping is greater than 5, so we have to round it up. That is, we have to add a 1 to the last digit that we are keeping, so it becomes 0.121. What about this case? 0.3172. We have to drop this, so we have to round it down. So drop this number, leave the last digit as it is, so it becomes 0.317. What about this case? 0.9188. This is the first significant digit, this is the third one. So we have to keep these three digits, drop this one, because the first digit that is getting dropped, or the only digit in this case that is getting dropped, is greater than 5. You have to round up, so you have to add a 1 to the last digit that you are keeping. So then the value becomes 0.919. Now in this example, this is the first significant digit and this is the third one. So we have to just drop this 0, and because the only digit that is getting dropped is less than 5, we simply remove that digit and keep the remaining number the same. So this is the answer for this example. What about this? This is the first significant digit and this is the third significant digit, so we have to drop this 5. Now because the digit that is getting dropped is 5, whether to round up or not depends on the last digit that we are keeping, and that is a 0, and 0 is an even number. So if it is an even number, you have to round down. That means you simply drop the digits that you are not interested in. So it becomes 000100. Again, in this case, this is the first significant digit and this is the third significant digit. So we have to drop this 5 because the only digit that is getting dropped is a 5. Whether to round up or down depends on the last digit that we are keeping, and that is a 7. And it is an odd number. If it is an odd number, you have to round up. That is, you have to add a 1 to the last digit that you are keeping. So it becomes 0.00000318. Now what about this example? Again, here 5 is the first significant digit and 2 is the third significant digit. So we have to get rid of 8, 9 and 7. Now the first digit that is getting dropped is an 8, which is greater than 5. So you have to round up. So you have to add a 1 to the last digit that we are keeping. So it becomes 573. Then what should we do with these remaining 3 digits? Should we simply say the answer is 573 and drop these 3 digits? Does it make sense? When you round 572,897 to 3 significant figures, do you get an answer as small as 573? It doesn't make sense, right? So in this case, what you have to do is you have to replace all the digits that you are dropping with zeros. So this is the value you would get when you round this integer to 3 significant digits. So sometimes you have to replace the digits that you are dropping with zeros. Sometimes you simply have to drop them. Now the next example is a bit tricky. It says round the number 6.0195 at 5. That is, it is asking us to get rid of this digit and any other digits to its right. In this case, this happens to be the last digit, so we simply have to get rid of this 5. See, this is different from the previous question. In the previous question, we asked these numbers to be rounded to 3 significant figures. That's not what we are asking here. We are not specifying the number of significant figures to which this number must be rounded, but we are asking to round this number at a particular digit. Now the only digit that we have to get rid of in this case is a 5, and if it is equal to 5, whether to round up or down depends on the last digit that we are keeping. And here it is a 9, an odd number, so you have to round up. So that is, to this number 6.019 we have to add 0.001, right? That is what we mean by adding a 1 to this digit. So 9 plus 1 is 0, 1, 1 plus 1 is 2, 0, 6. So the answer is 6.020. Now some of us may get confused and say the answer is 6.02. No, when you add 1 to 9, you would get a 10 and that includes a 0. So you must include this 0. So don't do this mistake. So rounding up digits that have a value of 9 or rounding up 9s is slightly tricky. So pay attention to that. For this question, the answer is 6.020, not 6.02. Now the next example says round the mass 8.99 grams and it tells nothing else. In this case, we have to round it to the nearest integer and we get tempted to say the answer is 9 grams, but there is a small problem with this answer. See, the original measurement is 8.99 grams. That means there is an uncertainty in this last digit and the implied uncertainty is plus or minus 0.1 grams when the uncertainty is not explicitly stated. But if you round this to 9 grams, then the implied uncertainty is again in this digit. This is the only significant digit, and if there is only one significant digit, then that is the uncertain digit. So we are not sure about this one. So the implied uncertainty is plus or minus 1 gram. So if you say the answer is 9 grams, then you are drastically increasing the amount of uncertainty. And that does not make sense. So in this case, the answer should be 9.0 grams. Now when you say the answer is 9.0 grams, that means there are two significant digits and this is the uncertain digit. And we are sure about this one, and in this case the implied uncertainty would be plus or minus 0.1 grams. So here also we are increasing the amount of uncertainty. Whenever you round a number, you are automatically increasing the amount of uncertainty or error in that measurement. That is what we call rounding error. But the difference is, in this case you are drastically increasing it, but here you are increasing it by a little bit, and this is what we need to do for rounding. So the answer to this question is not 9 grams, it is 9.0 grams. I think that covers all the scenarios as far as I can tell.